All right, welcome to another flip session of chemistry. We're getting towards the end here, guys. We have a few more units left, and we're going to wrap up the year. So we're sort of in the middle of gas units right now. We've been talking about the combined gas law. Here's a sample problem. So you have a gas, and the initial conditions, you got 1543 torrs, and that stands for torricellis or torricellis, which are a pressure unit for gas. And the volume is 600 liters with a temperature of 355 Kelvin. So those are our first initial conditions. Well, this gas changes here. The final conditions for the gas is 10.5 ATMs, a temperature of 200 degrees Celsius. Right? So we're going to warm up this gas, and we're trying to solve for V2, okay, using the combined gas law. And here's our conversion factor between torricellis and the ATM. There's 760 torrs per 1 ATM. All right. As always, take a stab at this, right? Pause the video and we'll go over it step by step. All right. Let's take a look how you did on this. Okay, so the first thing that sticks out to me is, well, my pressures are different units, and that's not going to quite work out for me. So I want to convert torrs, and I want to convert them to ATMs using this conversion factor, 760 torrs per ATM. And I also noticed my Celsius, right? This is a no-no for gas laws. We're not going to use this. So I'm going to add 273.15 to get this from Celsius to the temperature scale. So let's see how you fared on this. How did you do? So there's my first conversion. Right? 1543 torrs divided by 760 torrs per ATM. And the torrs are going to cancel out. If I can get this marker opened. All right, so the torrs cancel, and we're left with ATM. Notice 5 sig figs, because this number has 5 sig figs. Okay. 200 Celsius, we convert that to Kelvin by adding 273.15. And we know that, what are we solving for? We are solving for V2. Okay, so I have to transpose this equation around to get V2 by itself. Okay, so let's do that. So if you work your way through this problem and you transpose the variables, V2 is going to equal this expression here. So we plug in our values here, right? This is P1, this is V1, and this is T2, and this is T1 and P2. Notice by having my units the same, I can cross out my ATMs here. We can cross off the kelvins. And there it is. We're left with liters. So product divided by the product in the denominator. So 3 sig figs, because of these two numbers have 3 sig figs. We get an answer of 155 liters. Right? That's our solution. Right? Now some of you might be having some issues. How do I transpose this, right? Some of you can do this easily, you understand algebra, but how do I get V2 by itself? So if you're struggling a little bit with getting these variables the way you want them to be, always ask yourself, what is happening to the variable presently, and perform the opposite operation. So case in point, solve for V2. Okay, so V2 is right here. And two things are happening to V2 right now. It's being multiplied by P2, and it's being divided by T2. So do the opposite operation, right? If you are multiplying by P2, divide both sides by P2. Well, your P2s are going to cross out on the right side. Okay, so that gets rid of the P2. And you're dividing by T2, so multiply both sides by T2. and our T2s are going to cancel here. So now V2 is by itself. And that expression now is going to be this, right? T2 times P1 times V1 divided by P2 times T1. And if you notice, the temperatures cancel, the pressures cancel, and we're left with volume that does not cancel. Okay. All right, guys. As always, good luck on these, and we're going to start getting into the combined gas law, Dalton's law, and I believe that's going to wrap us up, okay, for the gas unit. So as always, keep on watching these videos. If you don't get it the first time through, watch it again. All right, that's what these are used for. And ask me in class any questions that you may have. All right, good luck on these, and I'll see you soon. Bye.